Yeah, this program. In that we have seen the number sum and factorials using the shift registers. And second, we have seen some logic gate operations. So this thing you can try. Suppose in this program, if I put instead of XOR gate, I put this AND gate operation. So AND gate, anything multiplied by 0 becomes 0. And if anywhere a 0 number is there, then only at 1 and 1, it will give me a high input. Otherwise, in all the other inputs, it will give me a 0. That's why purposefully I have selected an exclusive OR. You can choose any sort of operation, and you can have a multiple gates in cascade, and you can design your digital program. Okay, so okay, so this was the one case about the shift register. Now we can actually have another thing I wanted to explain as a shift register operation. So you can see that now there is only one shift register. Okay, now actually I can create a shift register in cascade in this particular case also. So just explaining. Putting a shift register in cascade is very much possible. So you see this particular program. Here there is a one shift register on the left, one shift register on the right. Now you can actually drag and drop this shift registers from the bottom. Now move your cursor. Okay. Now point towards the bottom of ये down arrow जो आपको दिख रहा है, just move your cursor over there and stretch it, expand it from the bottom. You see that multiple shift registers can be generated. I have generated 1, 2, 3, 4, 5, 6, multiple shift register. Actually, how I have done it? Just this is shift register. Move your cursor over there. Automatically, it changes to a expansion mode. My cursor, and I can drag and drop it. Now, suppose I put it as a 2 shift register. Now see that I know that in my first iteration, the output value is going to be 0. So 0 is being transmitted. But what if that particular value, in the second iteration, whatever output is there, if I want to do something else, then you can have a different logic. So there is another wire from here, and you can connect it to some different logic. Okay. So this thing, see that suppose now this value is going to be, suppose this value is going to be 1 XOR 0 is 1, and that one I wanted to connect to some other gate, so I can use a boolean, I can use an AND gate, and I can connect this one like this. Okay, I can give this switch operation like this, and I can create a one indicator. So what I did, I just stretch it. नीचे से जगह से थोड़ा सा एक्सपांड किया, इसका दूसरा वैल्यू आ गया that I given to and I have given this to a Boolean algebra. Now let's see. See, this program is very, very slow. Oh, I made a mistake. I didn't connect my LED. I connect this LED over here. Now see. See that third iteration and gate turn on. ओके, सो लाइक किसी भी इटरेशन का हम वैल्यू कॉपी कर सकते हैं. ओके, सो यू सी दैट इसमें जो सेकेंड इटरेशन का जो वैल्यू था वो मैंने एंड गेट के एक इनपुट को दे दिया और मेरा एंड गेट ऑपरेशन है अलग चालू हो गया. अगर आपको थर्ड इटरेशन का वैल्यू चाहिए, ड्रैग इट मोर and take a third iteration value and use it for your purpose. So serially अगर input like SISO serial input serial output करना है, so use a one shift register. Okay, if you want a second iteration value of the shift register, you can actually trap that data. So I think that someone from the faculty has asked that whether we can make a tabular form of that particular thing. Yeah, that's possible. Using an array, and apart from that we can have multiple LEDs on each operations. So that's also like I can stretch it below. Agar mujhe third iteration chahiye, so now there are 3 shift registers, 4th, 5th, 6th, so multiple times I can have these values and I can use it for my program. Okay, so this was all about the shift registers. So more you practice the shift registers, like more your mathematical concepts will get developed. Okay, so then after this, I'll just wait. So any doubt or anything you wanted to ask me about this particular session, please ask. I'm open to all your questions. Hello. Yes, Megha ma'am. So it's over to you, ma'am. Okay.
Yes, Sonia ma'am is going to declare that.
Okay.
Hello. Hello, Arpit sir.
Yes,
Sir,
ma'am.
I have one question.
Yes, ma'am.
Sir, what do you mean by this rising edge of a button?
Rising edge, I don't understand, ma'am. Where?
Yes, sir. What is the meaning of rising edge of a button? Means if switching on and off that you are doing na in shift register. So rising edge means what?
Rising edge. Where did you find, ma'am? Hello.
Yes, sir.
Yes, actually, ma'am, I don't understand your question. So, can you speak clearly, ma'am? What you want to ask?
Actually, sir, in PLCs also it is there. So whether we can write a code for PLC for Labview or not, or what
Okay,
is the meaning
understand.
of that? Right?
Yes, ma'am.
Yes, sir.
You're talking about the PLC, related to PLC, ma'am.
Yes,
Yeah,
yes.
rising edge and falling edge. That's what.
Yes, sir.
Yes, ma'am. So, in Labview, basically in the signal processing, there's a this pulse width modulations are there. In that,
Okay.
you can have your pulse design. You can design your duty cycle. You can design your pulse, and then you can give a trigger on the either on the rising or a falling edge.
Okay.
So that's possible in the LabVIEW, but ma'am, that's more related to the hardware. So
Okay.
that particular drivers, like whichever PLC you are using, that drivers has to be downloaded in the LabVIEW, and then we can have a digital triggering on a rising or a falling edge. Yes, ma'am. So it was a
Okay, okay, sir. Thank you. Thank you, sir.
Yeah, thanks.
Sir,
Yes,
am I audible, sir?
yes, sir.
Okay, I have a question. Actually, I have two.
Yes, sir.
So while loop, while you were discussing, you
Yeah.
had said that the while loop runs, for infinite number of times, and to control that, you had created the stop button.
Yes, sir.
So my question is, if is that the only way to control the while loop, or like we have in other programming languages, that while loop can be controlled by conditions. Some certain condition occurs, and the while loop.
Mhm.
can
Yes,
be
yes,
stopped.
definitely, sir. So, yes, so suppose, sir, this is a while loop is there. So as it is a digital logic, so some condition has to be connected to this while loop. So this is a while loop, and here you can have a digital control also. So suppose I create a constant. If I create a constant over here, it shows me false and true.
Okay.
So just to enlarge it. Yes, sir. So this is a false, and false and true we can have we can connect to a greater or equal or some in the hardware. Mostly this while loop condition is connected with the error. So
Okay.
suppose I connect an Arduino or Raspberry Pi, and if it shows me error that no Arduino, no Raspberry Pi is detected, directly that error wire connects to this loop condition, and
Okay.
automatically the loop stops. So, sir, this is a digital logic. We can connect it, but because for the beginners level, for the participants, I explained with the stop button.
All right, sir. All right.
Yes.
Thank you very much. I have one more question, sir.
Yes, sir.
And while you were discussing the shift register,
Yes, sir.
you had connected the indicator outside the loop.
Yes,
And
sir.
that created a problem that, if you're starting the operations
Yes,
after
sir.
having stopped it before, so whatever previous data existed in the shift register, that also added up to the shift register.
Yes, correct, sir.
Okay. And for that, you had suggested that, I add a constant to the shift register, constant of a 0, so
Yes,
that,
sir.
whenever you start running again, it will start from 0. So
Hmm.
my question was, is there any other way of clearing the content of the shift register without actually adding a constant there?
Sir, normally, unlike C, there is no such garbage value, but there is only a 0 is normally considered as a garbage value in the shift register. So if there is some addition operation and subtraction operation, it doesn't make any change if 0 is added or subtracted. But multiplying and divide, it's better than we give a constant as a 1.
Okay.
So that's what we can do. So as such, sir, we have to define something as a initial value, or we can initialize our input over outside the case.
Okay.
So yes, sir. So there is some limitation we can say.
Okay, sir. Thank you very
Yeah.
much.
Thanks.
Any more questions? Okay. Thank you, sir, for such a wonderful session. We'll end the session here and we'll meet at 1:50 sharp so that we can start the session at 2 o'clock. So all the participants are requested to join at 1:50 sharp. Thank you, sir.
Thank you.